we're going to look at the synthesis of purine nucleotides. This occurs in 11 plus steps. Steps 1 to 6 involves the creation of the small ring. Steps 7 to 10 involves the creation of the second ring. And from steps 11 onwards, we have first of all the formation of IMP. And from IMP, we have the formation of AMP and GMP. Step 1 involves the activation of ribose to form PRPP. We're familiar with this. It's catalyzed by PRPP synthetase. Steps 2 involves the commencement of the synthesis of the small ring, and it starts with the addition of NH2 to ribose to form beta-5 phosphoribosyl amine. That's step 2. It's inhibited by AMP and GMP, which are the end products of this pathway, and it's catalyzed by glutamine phosphoribosyl amidotransferase. From steps 11 onwards, we have IMP converted to AMP, which goes to ADP and ATP, and IMP converted to GMP, which then goes to GDP and GTP. You don't need to know the enzymes involved in this. What you do need to know, be aware of, is that there's cross-regulation. So GTP drives this reaction forward, and ATP drives this reaction forward. It's cross-regulated in that ATP is produced here and acts here, and GTP is produced here and acts there. In this slide, we look at the regulation of purine nucleotide synthesis. So this is the second step of the pathway, which is inhibited by AMP and GMP, the end products, and it's activated by PRPP, one of the precursors. And we can see further along towards the end of the pathway, the synthesis of GMP is inhibited by GMP, which inhibits IMP dehydrogenase. Likewise, AMP inhibits adenyl succinate synthetase. This helps to balance AMP with GMP, and the balancing of the bases is important for the synthesis of DNA because you tend to need equal amounts of the base that complement each other. This slide shows how simply and beautifully the enzyme glutamine phosphoribosyl amidotransferase is regulated. In the presence of either AMP or GMP, which are both end products of the pathway, a dimer is formed. The presence of PRPP favors the formation of an active monomer. So PRPP is able to drive the reaction forward, and either AMP or GMP restricts it. In the presence of AMP and GMP, when both end products of the pathway are present in sufficient amounts, the activity of the enzyme is switched off. So this allows the balancing of AMP and GMP